Hey guys, today we're going to take a look at 1.5, which is dealing with rational exponents and radicals. So first we're going to take a look at some radicals here. So remember, the principal nth root of a real number, so this is a radical to the nth root. This n right here is called the index of the root. Normally it's a square root. If it's a square root, you won't see anything there. But anything else, cube root, fourth root, that's the little number you're going to see telling you what root. Okay, and again, what it means is this number to that power will equal this. So what is the number that I would take to the third power to get this base right here? Okay, so for example, square root of 169. What number do I square to get 169? Well, that's 13. 13 squared is 169. You should probably know your perfect squares up to 15. After that, it's not really a big deal, and your calculator can do things bigger than that, but you should probably be familiar with that. How about this? This is the cube root of 125. What number times itself 3 times is going to equal 125? That's probably the biggest cube root I would expect you to maybe be familiar with. The answer is 5. 5 to the third power is 125. How about the next one? The cube root of negative 8. Now, you can't take square roots of negatives, but you can take cube roots because you're multiplying something times itself 3 times. So there's going to be 3 negatives in play. The first 2 will cancel out, but then that third one is still going to be there. So you can get a negative answer when you cube something. So in this case, the cube root of negative 8 is negative 2, because if you take negative 2 times negative 2 times negative 2, you will get negative 8. Okay? Now, some properties of radicals. First one, and this is a biggie that a lot of people have trouble with. If you are multiplying 2 radicals and they have the same index, again, normally that's just going to be a square root. Okay? If you've got a square root times a square root, you can multiply those 2 values and put them all over one symbol, under one square root sign. So like for this, if I have radical 2 times radical 3, that is the same as radical 6. Okay, so I can just multiply the parts that are under the radical sign. If I have the cube root of 3 times the cube root of 9, because those indices, that's probably the right word, are the same, then you can go ahead and you can multiply those together, and you can get the cube root of, well, 3 times 9 is 27. Now, when you do that, you want to stop and check and see if that happens to simplify. So in this case, 27 is a perfect cube root. The cube root of 27 is 3, so you would want to go ahead and get that as an answer. Okay, same way with fractions. Okay, if you are dividing and they have the same index, then you can put them all together under one radical. So it's one fraction under a radical. Now, this also can go the opposite direction. If you have a fraction under a radical, you can split that fraction up into 2 radicals, and then a lot of times you can simplify after you do that. Okay, if I'm taking the square root of 25 thirds, well, 25 is a perfect square. So I may want to re-split that up so that I can actually take the square root of the 25 and simplify it. So being able to go both directions is helpful. Okay. This next example would be an example of going the other direction with this one. I have one great big radical, okay, the square root of 18, and I'm going to simplify this because 18 contains a perfect square. Okay, 18 is 9 times 2. So if I re-split this up into the square root of 9 times the square root of 2, so I'm factoring that, okay, now I can take the square root of 9 and I can simplify it, and I can get 3 radical 2, which is the simplified version of radical 18. Okay, this would be an example of this right here, where you have one radical, and I'm going to split it into 2 pieces, the cube root of 8 over the cube root of 27, so that those numbers are going to be a little bit more familiar to me. Okay, the cube root of 8 is 2. I know that 2 times 2 times 2 is 8. The cube root of 27 is 3. 3 times 3 times 3. So the cube root of 8/27 is 2/3, which was a little confusing just looking at that fraction, but once I split it, I could deal with those separately, and it made a little bit more sense to me. Okay. Another thing while we're talking about fractions, one thing you need to know is that we don't like to leave our answers with radicals in the denominator. There's something about a radical. Remember, if it's not a perfect square, if you have a radical, that's an irrational number, and we don't like to have irrational numbers in our denominator. And so we do something called rationalizing. To rationalize a fraction, you simply, if I have like radical, so the square root of 3. If I take the square root of 3 and multiply it times itself, okay, square root of 3 times the square root of 3, using this principle up here, I would have the square root of 9. But that's a perfect square. So I could take the square root of 9 and I won't have a radical anymore. But if you're going to multiply the denominator by something, you also have to multiply the numerator by that same thing. Okay, so for example, if I have 2 over radical 5, I can't have that. So I'm going to multiply radical 5 times itself, because radical 5 times radical 5 is just 5, because it's radical 25. But I also have to multiply the top by that radical 5, and so 2 times radical 5 is 2 radical 5. Now, if you look at my original problem, and you look at my final answer, you may see a little trick, or a little something to do with both of these. Here's the trick. If you have a radical in the bottom, so just a single radical, not radical 5 plus 3 or something weird like that, okay, just a radical. Move the radical to the top, and then rewrite the number without the radical sign. That's it. Okay, so let's look at the next example. Using that trick, I would take the radical 3, move it up to the top, so 9 radical 3, and then I would rewrite the radical without the radical. So that is now rationalized. Now, that can also be simplified, because 3 goes into 9 3 times. I couldn't simplify here, but once I did this, I could simplify. So 3 radical 3. This also needs to be rationalized. Remember, if you have an entire fraction that's under a radical, it means that the denominator is under a radical. This is the same as radical 2 over radical 7. So I do need to rationalize it. But I can use this same little trick along with this property up here. If I'm going to move this radical up, that radical 2 is going to be multiplying a radical 7, which is radical 14. Okay, I can multiply them together. But then my radical 7 is not going to be under a radical anymore. And I get that. That is my final rationalized answer. Okay? All right, so next section. Radicals can also be written a different way. Radicals can be written using rational exponents. So remember, rational comes from the word ratio, which means a fraction. So this is an example of a radical, and this is an example of a rational exponent. So notice that the index, again, normally it's a square root, and you won't see an index there. We just know that it's a square root. But that index is the denominator of that exponent. Okay, so this is the connection, and the most important thing for right now is that you can go back and forth between these. If I give you a radical, can you turn it into a rational exponent? And if I give you a rational exponent, can you turn it into a radical? A lot of times you want to do that so it'll make a little bit more sense to you. So like some examples we're going to do down here. Okay, so also these two properties are also true, where if you're taking the radical of a base to a power, okay, this is what that rational exponent would look like. The exponent, the power, is in the numerator of that exponent, and then the index is in the denominator. Okay? You can also take the radical of a number, so take the square root of 5 or the cube root of 27, whatever. And then you can take the power of it after, but still, if you were to rewrite this as an exponent, that power is going to be your numerator, and that index is going to be your denominator. Again, going back and forth, both of these are the same. They're actually the same thing. It just tells you kind of, in this case, that order doesn't matter. You could either apply the power first and then take the root of that answer, or you could take the root of the base and then apply the exponent later. I'll show you an example down here why that is usually beneficial. Okay, but first two examples. Write in exponential form. So rewrite this as a exponent. It would be w to the 2/3 power. 2/3. That's it. That's all I need. And rewrite this as a radical. So this is a rational exponent. I don't know what 8 to the 1/3 power means. That doesn't mean anything. Okay, it's weird. We use rational exponents to be able to do math, which we're going to talk about in a second. But as far as simplifying this, I have to kind of stop and think about what that means. But if I rewrote this as the cube root of 8, now that is more familiar to me, and I know what that's saying. It's asking me what number times itself 3 times is going to equal 8, and I know that that is 2. Okay? All right. Look at the next example. What is 4 to the 3/2 power? Well, again, what this means is we're taking a square root, and we're also taking this to the 3rd power. Well, since 4 is a perfect square, let's apply this. Let's think of it in this direction. Let's take the root of that base, so let's think of the square root of 4, because that's going to make the number smaller. Then we're going to take that to the 3rd power. Okay, so the square root of 4 is 2. And then 2 to the 3rd power is 8. We also could have taken 4 to the 3rd power first, which is 64. And then if you took the square root of 64, you would get 8. So you get the same answer, but making the numbers smaller if you can first, and then making them bigger is usually the way you want to go on that. Okay, look at the next example. 25 to the, this is hard to read, but this was intended to be negative 1/2 power. Okay, 25 to the negative 1/2 power. So again, what does negative mean? It means that this is actually down in the denominator. So we're going to move it down to the denominator for in a second. But also the 1/2 power means we're taking the square root of this. So all in all, what we're really doing is 1 over the square root of 25, which you're all going to know is 1/5. Okay? All right, look at the next one. What is the cube root of 8 times p to the 6th and q to the 21st? So again, remember, what this means is it's 8 to the, well, I probably shouldn't do this, but to the 1/3 power, because we kind of know what the cube root of 8 is already without rewriting it that way. But it's also p to the 6/3 power and q to the 21st thirds power. So both of these can be simplified. Okay, 3 goes into 6 and 3 goes into 21. So this whole thing can be simplified as 2, because that's the cube root of 8, and then p to the 2nd, 6 divided by 3, and then q to the 7th.